Alright, let's talk about fraction operations. I'm going to show you how to do some of these things by hand, but mostly, for the most part, the emphasis is going to be on using calculators, and so I'll show you how to use calculators to do all these things. But it's helpful to know, what's going on, kind of, so that might help you. It's helpful to know how to do this by hand, so that you know how to punch it into your calculator correctly. So here's how we multiply fractions. So if you have two fractions, even if they have different denominators, if you want to multiply the two fractions together, all you have to do is multiply straight across. You multiply numerators with numerators and denominators with denominators. So it's really easy. For example, if you had 4 over 5 times 4 over 5, and you wanted to multiply those fractions, you just multiply straight across. 4 times 4 is 16. 5 times 5 is 25. And then I don't believe that reduces, so that's as far as that one goes. Now, if you wanted to punch this into a calculator, there are a couple ways that you could do it. You could just type it exactly the way it looks and say 4 fifths times 4 fifths, and then get the correct answer, 16 25ths. Or you could type it in like this. You could say, well, I'm going to end up doing the multiplication straight across, 4 times 4, and then I'm going to multiply the denominators 5 times 5, right? And again, get the correct answer. Or if you really wanted to, you could put each fraction in its own set of parentheses. That's not totally necessary, but it'll get you the correct answer as well. Okay. So let's take a look at another example. Notice that on this second example, we have different denominators, but that doesn't even matter because you can just multiply straight across. 4 times 3 is 12, 5 times 4 is 20. And then it says to reduce if possible. Now, we've already talked about reducing in the past, so the trick is you think to yourself, well, what's the largest number that goes into both 12 and 20? And I think the answer is 4, so I think you can divide by 4 in both of these locations and get 3 fifths as my final answer. And again, you could verify that punching it into a calculator, right? If we do 4 fifths times 3 fourths, then we get 3 fifths. Some of you might also know that there's a little trick here that you can do with cross-canceling, right? Because the 4 here cancels the 4 there and leaves a 1 in both cases, and so then it's just 3 fifths. If you don't know that trick, don't worry about it. Just don't worry about it. Just use your calculator. If you do know that trick, then you're welcome to use it. Okay, last one. Go ahead and give the video a pause. Try this one out on your own and see what you come up with. Okay, I'm going to give my answer now, so if you haven't paused and tried it on your own yet, then you should. But here's how I would do this. I would multiply straight across. 10 times 7 is 70. 23 times 15, now I'm not going to do that in my head, I'm just going to use my calculator. 23 times 15 is 345. I know that 5 at least will go into both of these things, so I know I can reduce by at least 5. 70 divided by 5 is 14. 345 divided by 5 is 69. Okay. Let's see. 14, 7 and 2 both go into 14. And 69, 13, I think, because 69 is 13 times 13. Is that right? Oh no, 13 times 13 is 169. 69. I know 3 will go in there. 69 divided by 3 is 23. So this is 23 times 3. 23 is prime, so I don't think that reduces. I think that's as far as that one's going to go. But again, you could check this in your calculator if you said, since I had to use my calculator to do 23 times 15 anyway, I might as well just say, might as well have just done the whole thing in my calculator, right? And yeah, 14 over 69. If your calculator's nice, it'll do the reducing for you. Okay, so that's that one. So that's how multiplying works. Let's talk about adding and subtracting fractions. So adding and subtracting fractions is where you do need a common denominator. Okay, so you have to have a common denominator. If you have a common denominator, then you just add the numerators or subtract the numerators, and you leave the denominator unchanged. Okay. Now, if you're going to be punching this into your calculator, it's important that you don't change these things into decimals until the very last step. Okay, and this example shows you why. If you add the fractions the way that you should, 1/3 plus 1/3, well, you should add the numerators. 1 plus 1 is 2, so you should get 2/3. 1/3 plus 1/3 is 2/3. That makes sense. And now if you change that into a decimal, 2/3 is approximately, if you round to 4 decimal places, here, we can do this in the calculator. 2/3 as a decimal is 0.66666 repeating forever. So if we were to round this to 4 decimal places, we would get 0.6667. We'd have to round up to 7. Okay, but what if you change these to decimals before you add, right? Well, if I change 1/3 into a decimal, I'm going to get 0.33333 repeating forever. So rounding to 4 decimal places, this is approximately 0.3333 plus 0.3333. And if I add those two things, I get 0.6666. And you can see that I'm off, right? I'm off. So the moral of the story is, if you're going to change the fractions into decimals, don't do so until the very last step. Okay? Leave them as fractions until the very end. Otherwise, you're going to end up with rounding errors in your answer. Okay. Now, if you did want to do this in your calculator as fractions, then you could just enter it the way that it looks, 1 divided by 3 plus 1 divided by 3. Or if you wanted, you could do one step before the calculator and do 1 plus 1 divided by 3. If you do it that way, make sure to put the numerator in parentheses. Okay. So, a couple examples. 3/10 plus 5/10. I know that I can just add straight across and get 8/10. Now that reduces because 2 goes into both of those numbers, so I know I can reduce by 2 and get 4/5 as my final answer. If you punch this into your calculator, you can do it like this: 3/10 plus 5/10, and it just gives, my calculator will just give me the reduced version, 4/5. Okay, same thing works with subtraction. So go ahead and pause the video, give this a try. Okay, here's my solution. 17/36 minus 6/36 should be 11/36. That's really hard to say. And I don't think that reduces because 11 doesn't go into 36 and 11 is prime, so that's as far as that one will go. On number 3, I want to show you that you can do this with both addition and subtraction, and again, don't worry about the denominators. As long as the denominators are the same, you can go ahead and add and subtract the numerators all you want. So I can do 16 plus 7. So 16 plus 7 is what? 23. And then minus 5 should be 18. So you should end up with 18 over 52. You can reduce that though. We can reduce by at least by 2. That would give us 9 out of 26. 26 is 13 times 2. So I don't think that's going to reduce. I think that's as far as that one's going to go. But again, you can throw this into your calculator, right? 16 over 52 plus 7 over 52 minus 5 over 52 is 9/26. Just like you should get. Okay. So that's how we add and subtract fractions that have a common denominator. Now, it is possible that you could end up with fractions that have different denominators. However, when we're dealing with probabilities, that usually doesn't happen. That usually doesn't come up. Usually we have common denominators because we're looking at, the number of ways something can happen divided by the total number of possibilities. And so the total number of possibilities is going to be in the denominator, and that's always going to be the same in the problem that you're looking at. If you did happen to need to add fractions that have different denominators, just use your calculator. It's fine. You know, if you had 2/5 plus 3/7 or something, your calculator will handle this just fine. Okay, and give you the answer in a fraction form. Okay. When we're dealing with probabilities, though, we do oftentimes have formulas that we use for various things. So, for example, if we're looking at the probability of A and B, and we'll talk about what this means when we actually cover these formulas in the stats course. But for now, let's just suspend your disbelief a little bit. And let's say that we wanted to compute probability of A and B. Well, it turns out that the probability of A and B is just the probability of A times the probability of B in certain circumstances, which again, we'll talk about in the stats course. So let's compute probability of A and B if we know that probability of A is 2/5 and probability of B is 1/3. The instructions say that if the problem is given with fractions, leave your answer as a fraction and reduce. If the problem is given with decimals, then leave your answer as a decimal and round to 4 decimal places. So in this case, we were given fractions. We're going to leave our answer as fractions. So we're asked to find probability of A and B given this information. So we know probability of A and B is going to be probability of A times probability of B. That's probability of A, 2/5, times probability of B, 1/3. And then you can throw that into your calculator to get the answer, or you can multiply straight across if you prefer. This is 2/15. And that's as far as that one will go. Okay. Another formula for the probability of A and B is that probability of A and B is probability of A times probability of B given A. That's how we read that second little probability. Probability of B given A. Now, again, this is something we'll discuss in the stats course. For now, I just want you to focus on actually doing the multiplication, right? So we're asked to once again find probability of A and B. Well, we know probability of A and B is probability of A times probability of B given A. Probability of A is 2/3. Probability of B given A is 9/11, apparently. And so you can throw that into your calculator now, or you can do the multiplication by hand if you prefer. This is 18 over 33, right? 2 times 9, 18. 3 times 11, 33. I know that 3 goes into both of those numbers, so I can reduce by 3. And that gives me 6/11, and I believe that's as far as that one goes. Okay? Go ahead and give number 3 a shot. This time we are given decimals, so leave your answer as a decimal and round to 4 decimal places. Okay, here's my solution. We're asked once again to find probability of A and B. It's probability of A times probability of B. That's going to be 0.3275 times 0.2788. So I'm just going to use my calculator for that. 0.3275 times 0.2788 is that number, but we're supposed to round to 4 decimal places, right? 1, 2, 3, 4. So I look at the next digit, it's a 0. That means I'm going to leave this a 3. So this is approximately 0.0913. Okay. Number 4. It says to find probability of A or B. And we're told that probability of A or B is probability of A plus probability of B. That's a true statement in some circumstances. So we can say, alright, it's probability of A, 3/10, plus probability of B, 4/10. We add those up, we get 7/10. And that one does not reduce, so that's the final answer. Okay. Number 5s may be a little bit more complicated. Go ahead and give it a shot though. So see if you can figure out, we're supposed to find probability of A or B. So go ahead and give the video a pause and see if you can figure that one out on your own. Okay, so here's my solution. So I know probability of A or B is going to be probability of A, that's 5/12, plus probability of B, that's 7/12, minus probability of A and B, that's 3/12. So minus 3/12. Okay. At that point, I can just throw this all into my calculator and see what I get, or I can do some of it by hand. 5 plus 7 is 12, minus 3 is 9, so this is 9/12, and I know that that reduces by 3. So I get 3/4 as my final answer. Okay. Again, you could punch that into your calculator instead. You could just say 5/12 plus 7/12 minus 3/12 is 3/4. Okay, and number 6. Once again, this time we're given decimals. Round to 4 decimal places if needed. I don't think you'll actually have to do any rounding here, but yeah, go ahead and give the video a pause and see if you can get this one on your own. Okay, so here's my solution. Probability of A or B is probability of A, that's 0.45, plus probability of B, that's 0.25, minus probability of A and B, that's 0.05. So this is going to be 0.7 minus 0.5, so 0.65. You could throw that into your calculator though. Alright, 0.45 plus 0.25 minus 0.05 is 0.65. Okay, so that's that one. So that's the context with which we will be doing multiplication and addition and subtraction of fractions and decimals and stuff. It really is not going to get that much more complicated than that. However, there may be some occasions when we'll need to solve some equations. These things come up occasionally, not very often, but they do come up occasionally throughout this course, and in particular they'll come up in a couple of problems that you'll do involving these probability formulas that we saw on the previous page. So let's just remind ourselves how solving linear equations works. Basically, the idea is if you want to solve for x, then you have to undo all of the operations that are currently being done to x, and in order to do that, you perform the opposite operation, and you do that on each side of the equal sign. Okay. In order to keep your equation balanced. In other words, if I decide to subtract 4 from the left side of the equation, then that's perfectly legal as long as I also subtract 4 from the right hand side of the equation so that the equation remains in balance. Okay? So, for example, number 1 here, I have x plus 5 equals 12. Now, some of you might be able to look at that and do it in your head and figure out what x is supposed to be in order to make this statement true, just by inspection, right? You might look at that and say, well, what plus 5 equals 12? And then you figure out, well, it's 7, right? Because 7 plus 5 equals 12. But to show those steps algebraically, and by the way, the reason we want to show them algebraically is because you might end up with a more difficult problem, let's say, that's not as easy to do in your head. And so we learn how to solve these things algebraically in order to deal with those more challenging scenarios. So the way that we do this algebraically is we say, okay, we want to get x by itself. Right now we're adding a 5 to the x, so in order to get rid of that plus 5, I need to subtract a 5. And I'm allowed to do that as long as I also subtract a 5 from the other side of the equation. And if I do that, I'm just going to be left with an x on the left, and then a 12 minus 5 is a 7 on the right. So x equals 7, just like we suspected. Okay. Now if you look at number 2, you've got a similar type of situation, only instead of adding something to the x, we're multiplying something by the x. In this case, we have 2x, and the assumption is that when there's no operation written, that the operation is multiplication. So 2x is really the same thing as saying 2 times x. 2 times x. And if I want to undo that multiplication, I need to divide. So I'm going to divide by 2 in order to get x by itself. And I'm allowed to do that as long as I also divide the right hand side by 2. So if I divide the left by 2, I'm left with x. If I divide the right hand side by 2, 12 divided by 2 is 6. Okay? So in general, this is how solving equations works. We might need to do some simplifying first. So on number 3, I'll show you 2 ways that you could do this. One way would be to go ahead and add 3 to both sides to get rid of the 3. And then we'll have an x plus 11 equals 17. Okay? And then the next thing we would need to do in order to get the x by itself would be to subtract the 11. Okay? And then you're left with x on the left and a 6 on the right. So that's one way you could do it. Another way you could do it would be to simplify first. So I'm going to erase this. And we could simplify first. What I mean by that is we can combine anything that doesn't have an x on it. In this case, 11 minus 3, those are like terms, okay, because neither of them has an x on it. And so I can just go ahead and do 11 minus 3. 11 minus 3 is 8, right? So I can say the 11 minus 3 becomes an 8. So this is x plus 8 equals 14. And then I can go ahead and try to solve for x. I'm adding 8 to x, so I need to undo that by subtracting 8. So I subtract 8 from both sides, and I get x equals 6, just like before. Okay. So with that in mind, go ahead and try out number 5. We'll come back to number 4 in a second, but go ahead and try number 5 on your own. Give the video a pause, see if you can end up with the correct answer. Okay, I'm going to give my solution now. The answer you should end up with is x equals 4. Okay, but again, I'll show you 2 ways you could get it. One way would be to start to undo all the stuff that's currently being done to x. For example, I'm subtracting a 2, so I could add a 2 in order to undo it. And I'm allowed to do that as long as I do the same thing on the other side as well. I would be left with 5 plus x equals 9. And now I think, well, what else am I doing? I'm adding a 5 to x, so I need to undo that by subtracting a 5. And I get x equals 4. Okay? So that's one way to do it. Another way we could have done it is we could have said, well, first I'm going to combine the like terms. I've got a 5 and I've got a negative 2. So if I combine those 5 plus a negative 2 would be a 3. So I have 3 plus x equals 7. Right? So this is another way that I could have done it. And then I could have said, well, I need to subtract a 3 in order to get x by itself, and I get x equals 4. Okay? So that's how we do number 5. Okay, but now let's go back to number 4. Okay, number 4, we have 3x plus 5 equals 11. This is going to be a 2-step process because I don't have any like terms to combine or anything like that, but I do have two things that I'm doing to x. I'm multiplying it by 3, and then I'm adding 5. So I need to undo that. Now the thing to realize is that in order to undo that, we should work backwards. So using order of operations, usually, so we would do the multiplication first, and then we would do the addition. But in order to undo all of that, I need to undo the addition first, and then undo the multiplication. Okay, so I'm going to undo the addition first by subtracting a 5. On the left-hand side, we'll be left with a 3 times x. On the right-hand side, we'll be left with 11 minus 5 is 6. And then I can do that multiplication by dividing by 3. We'll be left with an x on the left. 6 divided by 3 is 2 on the right. Okay. Now, you might ask, well, but why do we need to undo the addition first? And really the answer is you don't have to. You could have undone the multiplication first if you wanted. So starting with 3x plus 5 equals 11, you could have said, well, I'm just going to go ahead and divide by 3 first on both sides. When you divide by 3, you'll end up with an x plus a 5/3, right, equals 11/3. And then you could subtract that fraction, and you'd get x equals 11/3 minus 5/3. Those have a common denominator, so you can subtract the numerator like we just talked about. 11 minus 5 is 6. And then you can reduce 6/3. 6 divided by 3 is the same thing as 2. So you get to the same place. It just takes you a little longer. So I think the better thing to do is undo the addition first, and then undo the multiplication. Okay, so with that in mind, let's give number 6 a try. So go ahead and pause the video and see what you get. Okay, here's my solution. So I would start off by combining like terms. 10 plus 3 is 13. Then I would try to undo what's being done to the x currently. So currently I have this positive 13. I need to undo it by subtracting a 13. And then I'll be left with a negative x on the left. And I'll get a negative, oh, what would this be? 13, 12, 11, 10, 9, 8, of negative 8 on the right. And so now I've solved for negative x, but I don't want to solve for negative x, I want to solve for positive x. So I finish by dividing by negative 1, and I get x equals 8. Okay, there are other ways that you could have done number 6, but as long as you ended up with x equals negative 8, then you probably did it right. Okay, it's possible sometimes you make 2 mistakes, but the mistakes correct each other, and you end up with the right answer by accident. So I'm not going to say 100% that you did it correctly if you got x equals 8, but you probably did it correctly if you got x equals 8. If you have any questions, go ahead and post them in the discussion board for this worksheet. One thing that I will point out is that these last 2 problems, number 4 and number 6, these are probably not going to come up as often as something like, say, number 1 or number 3. These kinds of problems will come up more often in this class, and so if you were okay with those, then you're probably okay. You know, I wouldn't worry about this stuff too much if it kind of went over your head a little bit. Okay? In fact, let me show you now the context in which this kind of thing will pop up when it comes to probabilities. So, so here's how this kind of thing will come up, and here we'll do an example with some decimals. But it says use probability of A, use this formula, right? Use this formula right here. Probability of A or B equals probability of A plus probability of B minus probability of A and B. So we're going to use this formula to solve for probability of B, this little middle term. And then we're given a bunch of other information. So here's how we're going to do this, right? So we know probability of A or B equals probability of A plus probability of B minus probability of A and B. And by the way, if I'm going too fast, give the video a pause. You can rewind it, whatever. But this is the formula we're starting with. Now, we're going to go through and plug in the information we were given. We were told that probability of A is 0.62. So I'm going to replace the probability of A with 0.62. We were told probability of A and B is 0.25. Okay, so I'm just replacing the pieces. We were told that probability of A or B was 0.60. Okay, and the only thing we don't know is probability of B, but that's exactly what we're supposed to solve for. So you can either leave that probability of B, or if that confuses you, you could just call it X and then solve for X. Okay, and so now this is a problem that's very, very similar to number 5 up here, right? Very, very similar. Only instead of whole numbers, we have some decimals. Don't let that freak you out. You're still going to solve this exactly the same way. We want to solve this for X. So I'm going to start off by combining these like terms. I have a positive 0.62 and a negative 0.25. I'm just going to use my calculator here and say a positive 0.62 minus a 0.25 equals 0.37. So I'm going to write down this whole thing again, 0.60 equals, and now it doesn't matter if you write 0.37 plus x or x plus 0.37. It's the same thing. So however you want to write it, I'm going to write this as x plus 0.37 because I combined these two things to get the 0.37. Okay? And the x just kind of comes along for the ride there. Okay, now I need to get x by itself. So I need to undo the operations that are currently being done to the x. So currently I'm adding a 0.37 to the x. I need to undo that by subtracting a 0.37, which I'm allowed to do as long as I also subtract 0.37 from the other side of the equation. And once again, I'm just going to use my calculator. 0.60 minus 0.37 is 0.23. And then I'm done, right? So that must be, remember that we replaced probability of B with X, so this must be probability of B, right? So probability of B equals 0.23. Okay. And that's how we do those types of problems. So with that in mind, we can kind of put everything together now, and I've got 4 examples on this last page that that I want you to work on and see if you can figure out on your own. Okay, so go ahead and give the video a pause. I'm going to work out these 4 examples in a little while, but go ahead and give the video a pause, see if you can do these on your own. Okay, here are my solutions. So number 1, we're supposed to solve for probability of B using this formula. We're told that probability of A is 0.132, so I'm going to replace that here. Probability of B, I'll just call that X, I suppose. Probability of A and B, we're told, is 0.102. So this is what we've got. So if I want to get X by itself, I'm going to divide now by 0.132. So 0.102 divided by 0.132 is 3.1875. So I'm going to say 3.1875 equals X, and I'm done. Okay, so that's number 1. Number 2, we're supposed to solve for probability of A using this formula. We're told that probability of B is 0.15, and we're told probability of A or B is 0.65. So I can solve for probability of A by subtracting 0.15. You can go ahead and punch that into your calculator, but I think you're going to get 0.5 equals x. Okay, so there's number 2. Number 3. So we're supposed to solve, again, for probability of A using this formula. We know that probability of B given A is 0.75. Probability of A we don't know. We're asked to find it. And probability of A and B we're told is 0.2. So I can solve for x here. I'm multiplying by 0.75, so I undo that multiplication by dividing. Okay? So 0.2 divided by 0.75. Well, I should round this probably, right? So I'm going to round to 4 decimal places. This is 1, 2, 3, 4. I look at the next decimal, it's a 6. So that means I need to round this one up to a 7. So this is 0.2667 approximately. So I'm going to say 0.2667 is approximately x. Okay. And then last one. Okay, we're supposed to solve for probability of A and B using this formula here. I'm going to rewrite the formula so that I have room to make my replacements. This is what I want to solve for. So I'm going to replace this with an x. Okay. Then we're told probability of A or B is 0.9323. So this I'm going to replace with 0.9323. We're told probability of A is 0.4125. And we're told that probability of B is 0.5892. So I can now solve this for x. First thing I'm going to do is combine these like terms. I'm just going to use my calculator and do 0.4125 plus 0.5892. Whoops, I had an extra decimal in there. That comes out to 1.0017. .0017. Next thing I need to do to get x by itself would be, I've got a positive 1.0017 here, so I need to subtract a 1.0017 in order to get rid of it. And I'm allowed to do that as long as I do the same thing to the other side as well. So let's see. 0.9323 minus 1.0017 is negative 0.0694. And on the right hand side, I'll be left with, those are gone, so I'll be left with a negative x. Now, I want to solve for positive x, so I should divide by a negative 1. And I'm left with 0.0694 equals x. Okay. So that's the probability of A and B. All right. So that's that. That's all there's. That's as difficult. So this problem right here, number 4, this is about as difficult as these kinds of problems are going to get. So if you're okay with this one, then you should be okay with all the solving that we have to do. Okay, so that's all the background information you'll need in order to complete the rest of Chapter 5 without any problems. So that's that. Check in with you later.